Hello friends, welcome back to my channel. So today I am going to teach you trigonometry. I am going to give a chapter overview, and this is our second video, our second session. So let's get started. Today I am going to explain you what are people usually use these terms named sine, cosine, cos, tangent, cotangent. So I am going to explain you what are those. Let's take a right angle triangle. Right angle is always going to be 90 degrees, and according to the angle sum property, revise it, remember it. Angle sum property, you have studied it in 8th class, 7th class. Remember, revise it, recall it in your brain. Sum of interior angles is equals to 180 degrees in a triangle. People who know, no worries. People who do not remember, recall it in your mind. And if you don't remember, just buttify it. Okay. And now let's name our triangle A, B, C. So if one side is going to be, if we consider one side as theta, the other angle is always going to be 90 minus theta. How? I'll prove you. Let's take this angle as 50 degrees. And according to our property, angle A plus angle B plus angle C is always 180 degrees. What's our angle A? Angle A is theta, 50 degrees. 50 plus B, our right angle, 90 degrees, plus C. We don't know C, so let's assume C as X is equals to 180 degrees. 90 plus 50, 140. 140 degrees plus X equals to 180 degrees. Therefore, X equals to 180 minus 140 degrees, which is nothing but X equals to 40 degrees. Now we have gotten the value X equals to 40 degrees. So if our theta is 50, let's do 90 minus 50. That's nothing but 90 minus theta. Theta is 50. Let's substitute theta value. 90 minus 50 is nothing but 40. So we get the same value. That's the reason if one angle is theta, the other angle is always 90 minus theta. Yeah. Always remember this property, angle sum property. Interior angles of a triangle are always equal to 180. So yeah. Now, people generally use the term sine. What is sine? Sine is nothing but the ratio. If we consider angle this as theta, it's going to be 90 minus theta, right? And if it's going to be theta, this is going to be 90 minus theta. So if you take any angle theta, let's take this, the opposite side to this angle, this, let's call it's BC. BC is equals to opposite to theta by our hypotenuse. Remember, the side which is always opposite to the right angle is the hypotenuse. See, this is our 90 degree angle and this is the hypotenuse. By hypotenuse AC is equals to this hypotenuse. The ratio of opposite and the side opposite to theta and the hypotenuse, this ratio is known as sine. We calculate sine ratio using this method. If suppose anybody gave a triangle PQR, my drawing is not good, please adjust. PQR, a right angle is at Q, they had mentioned. So we take it as theta, this is 90 minus theta, and if And if they gave the hypotenuse 13 centimeters, then find the, and this is say some 60 degrees, so it's going to be 90 minus 60, 30 degrees, and it's 90. So they say to find out the value of QR. In this case, this, if we take this as theta and this angle as theta, in our case this angle is opposite to this side, so we can write it in a terms of sine, because opposite by, and this is our hypotenuse, remember it, right angle, the right opposite side to right angle is always hypotenuse, and they have given the hypotenuse, so we can find out the value of this using two ways. But now I am going to say one way, with the sine ratio. This angle is opposite to that, so we write sine theta equals to opposite to theta by hypotenuse. Sine theta, what is the value of theta here? It's 60. Sine 60 is nothing but opposite, that's x, is equals to, wait a minute, sine 60 is equal to x by hypotenuse 13. What's the value of sine 60? What's the value? Root 3 by 2. If you don't know the ratios of sine, the values of sine ratios, all the trigonometric ratios, check out my previous video. I have explained them in detail, and even today I am going to explain it. I am going to recall. See, 1 2 3 4 5. See, I am going to explain sine and cos, that's it. And I have done a trick in my previous session, so you can check out there, but for now I am explaining it in a brief way. This is sine, this is sine, and this is cos. 0, 30, 60, 45, 90. Sine 0, 0. Sine 30, 1 by 2. Sine 60, 1 by root 2. Sine 45, Sine 45, 1 by root 2. Sine 60, root 3 by 2. Sine 90 is 1. And just reverse reverse this order and you will get the cos values. Cos 0, 1. Cos 30 is sine 60, root 3 by 2. Root 3 by 2. Cos 45, sine 45, both are same, 1 by root 2. And cos 60, it's sine 30, 1 by 2. And cos 90, sine 0, 0. So remember these two, and you even need to remember tan. I'll write even the values of tan. Tan 0 is 0. Tan 30, 1 by root 3. Tan 45, root 1. Tan 60, root 3. And tan 90, not defined. So you need to remember these three values, and you can reciprocalize them, and you can get the remaining values of cosecant, secant, and cotangent. Back to our example. X by 13. So sine 60. What is the value of sine 60? Root 3 by 2. Root 3 by 2 is equals to x by 13. 13 root 3 is equals to 2x. Therefore, x equals to 13 root 3 by 2. By transposing 2 to this side, 2 to a left hand side, we get 13 root 3 by 2. This is the value of x. This is how we find out values of sine, cos and tan in our board exams. But in board exam point of view, the work you have done and the presentation matters a lot. So Work hard for your presentation. Next. And you know the sine is opposite to theta, side opposite to theta by hypotenuse. Let's just write HYP so you can understand it. And cos is adjacent. Adjacent is nothing but the lying side. This side is lying to the angle. If we take this as theta, this is the lying angle. We can't take this because it's the hypotenuse. The hypotenuse is always fixed, but the adjacent side and the opposite side always change with the perspectives of theta with the angle theta. So cos ratio is nothing but adjacent by hypotenuse, A by H, and tan is nothing but opposite by adjacent. Opposite by adjacent. This side is adjacent, this side is opposite. We can't take this as adjacent because it's fixed. And tan opposite by adjacent. These are the three important ratios. And now let's solve some problems. I am going to explain you some problems. So let's suppose in a right angle triangle PQR. If a triangle is right angle at Q, then we can take P here or here. So I am taking P as here and R is here. PQ is 5 centimeters. QR is 12 centimeters. Then find this side. By using Pythagoras theorem, we can easily find the sides because recall the Pythagoras theorem. Theorem. Opposite square plus adjacent square is always equal to the square of the hypotenuse. So here, this is our hypotenuse x, and these are the opposites and adjacent, whatever. So let's write it here. O square plus a square is equals to h square. Opposite, let's take this. We can take opposite anyway because they didn't mention the angle theta and 90 minus theta. They didn't mention from which perspective we need to see the angle. So let's take this as theta and opposite to it 12 square plus adjacent 5 square equal to x square. What's 5 square? 25. 12 square 144. 144 plus 25 is equals to x square. 169 is equals to x square. Therefore x square equal to root over 169 root over 169, that is 13. So the length of this side is going to be 13 centimeters. Remember the Pythagoras theorem. And next, let us take a square. Each side is 90 degrees, right? Every side is 90 degrees in a square. This side is 10 centimeters. And remember the formula of the diagonal. if side equals to A, then the diagonal is equals to always A into root 2. That's the value you need to remember. So if we cut it like this, then find the value of the diagonal. Simple. No need to use this formula. We can use trigonometry and solve this problem. See, if we cut this into equal halves, we get this angle bisected into 45 degrees and 45 degrees. If this is 45, this angle is 90 minus 45. If this is theta, this is 90 minus theta. 90 minus 45 is 45. Or no need to, if you don't want to use that, you can calculate by the bisection. Here also it is bisected in equal halves, 45 and 45. So we can use, if we take this as theta, this is a hypotenuse, and this is, we can use tan ratio. We are given with adjacent side and we need to find the opposite. There is no work of the hypotenuse, so never get tensed by seeing there is no hypotenuse given. You can use some ratios like tan and cotan, which are not used by, which are not involved in hypotenuse side. So we are given with adjacent side, need to find the opposite. So tan theta equals to opposite to theta by adjacent to theta, adjacent ADJ to theta, which implies sin 45 is equals to opposite. Let's name it x by 10. So what is, sorry, it's not sine, I wrote sine, sorry. Tan 45 equals to x by 10. What's the value of tan 45? I've just shown you. Tan 0 0, tan 0 0, tan 30 1 by root 3, tan 45 1. So 1 equals to x by 10, and here it's in the form of division, and when it comes here it becomes multiplication. Therefore x equals to 10. So now they say to find out the hypotenuse. So we have two methods. One, using the Pythagoras theorem. Now we have x equals to 10. So we can use the Pythagoras theorem to get the hypotenuse side, or we can use trigonometric ratios. I am going to show the both methods. Method 1, by using Pythagoras theorem. 10 square plus 10 square equal to hypotenuse square. 100 plus 100 equals to hypotenuse square. Hypotenuse square equals to 200. Therefore hypotenuse equals to root over 200, which can be written as 100 into 2. Root over 100 into 2 can be written as 10 root 2. So this is our final answer. And in method 2, I am going to use trigonometric ratios. We have both the sides except the hypotenuse, so we can consider any angle, this or this. We are going to get both. In both the cases we are going to get the same answer. So let's take this as theta. So we have adjacent. This is the adjacent in contact, or we can use the opposite. Let's use adjacent. Adjacent by hypotenuse. Which ratio? Cos theta. Cos theta equal to adjacent to theta by the hypotenuse. In here the theta is 45 degrees. So cos 45 is going to be, what's adjacent? 10 by What's the hypotenuse? It's not given. Let's take it x by x. What's the value of cos 45? Cos 0 1, cos 30 root 3 by 2, cos 45 1 by root 2. So 1 by root 2 is equals to 10 by x. By transposing these two here and these two here, we get both the answers. We get x multiplied to 1 here, and when we transpose it to here, we get root 2 multiplied to 10. Therefore 1 into x equals to 10 root 2. That's nothing but x equals to 10 root 2. Are both the answers same? See, nothing. When there are two numbers inside, we multiply them, and we multiply to get a square number, perfect square, and we take it out by using its square root and write it in the form of square root and the remaining number inside. Nothing. And I suggest the simplest way is to find using the Pythagoras theorem, because no much work to do. Now I am giving you a home task to complete. I would hope that you will complete the home task and comment it in the comment section. Let's take a right angle triangle. A, B, C, and let's give this 10 by root 3. Theta 90 minus theta. Let's give theta 50 degrees. So your home task is to solve both, find out the both adjacent side and the opposite side. I have given you the hypotenuse, which is 10 root 3. So you need to find out the hypotenuse and the adjacent. This is your HT, home task, right? Till now, if you have liked watching my video, please subscribe to my channel. Please like the video. Please support me. And yeah, that's next. I am going to give you a table of specific angles of trigonometric ratios in the next class. I am giving you a total table in the next class, and I am going to give you some solved questions which are from. I am going to explain you some higher level questions, some high order thinking, some hard questions, and I will meet you in the next session. Till then, goodbye.